if you take sine 2a, and I rewrite that as sine of a plus a, because a plus a is 2a. And then I recognize that that is this double angle, some identity of a sine function here. So I can rewrite it as sine of a cos of, well, here it is, sine of a cos of a plus cos of a sine of a. These are the same thing, right? Sine a cos a plus cos a sine a is the exact same thing, so that just means it's 2 sine a cos a. That's the double angle identity. If you have sine of 2a, you can rewrite it as 2 times sine of a cos of a. It's called a double angle identity because if you notice, this is 2 times a, and then when you rewrite it in this other form, it's just a. It's been cut in half, or if you go this way, it's been doubled. All right? No. It's this one. Okay, that's just the proof. You don't have to know the proof. That's just where it comes from. Okay, and you could do the same for all the other ones. I'm not going to do them. What you need to know is how to use them. All right, they are on your sheet. They're at the very bottom of your sheet. On your sheet, they're right there. There they are, right there. Boom. All of them. There's the tan one too. Those are all the double angles. All right. So, how do you use them? You're going to be required to use them in proofs. So, we're going to prove this identity right here. When you're doing a proof, and I'll tell you right now, the one that you're going to have on your test is going to have a double angle in it. They're easy to identify because everything will be x, except something will be 2x or 4x or something like that. It jumps out at you. If you see that, you need to get rid of the double angle. So I need to rewrite sine 2x in terms of x's. So what does sine 2x equal?
2 sine a cos a.
That's it. That's all you do. You will get a mark if you do that. All right, the proof is out of 5. If you get rid of the double angle, you will get a mark. Now, you can't really do anything else to that side. Okay? It's sines and cosines. You can't do anything. So now we go to the other side. What can we do to the other side? Okay, so usually we write all the tans as sines over cosines. However, and you can do that and you'll get the right answer, but does anything else jump out at you? Yes. This thing, trig function squared plus 1. What's 1 plus tan squared? Secant squared. Now, the reason you want to do that is because then you're not generating something plus a fraction, right? Where you're going to make a common denominator and put them together. This is going to be a lot quicker now. So now you can convert everything to sine and cosine. So tan is what? Sine of x over cos of x. And what's secant? And so secant squared is 1 over cos squared. Perfect. We have a fraction over a fraction. What do you do? What happens? And you're left with? And you're done. I just changed them from x's to a's. That should be x's too. Okay, so you're done. So if you see a double angle, get rid of it. It's your first step. Get rid of it. It's a no-brainer. Okay? All right. All right, now we're going to just practice breaking these up for a sec. Just so you understand what is actually happening with the double angles. So if I have sine 6x and I want to rewrite it using a double angle identity, what does that become? The only choice you have is this, okay? What happens to the angle as you expand it into sine and cosine? It becomes half of the original, right? We went from 2a to a. So in other words, if I have sine of 90 degrees, that is going to be the same as 2 times sine of 45 degrees cos 45. The angle gets cut in half when you're going that way, okay? 2a becomes a, 90 becomes 45. So if you're going this way, what happens to the angle? It doubles, okay? Hence the name double angle identity. And that works for all of them. The cosine ones, now there's 3 cosine ones. I think your sheet has all 3. Does it? Yes, it does. So there's 3 cosine ones. Cos 2a can be cos squared minus sine squared, or it can be 2 cos squared minus 1, or it can be 1 minus 2 sine squared. If you want to see those proofs, come see me. I will show you the proofs. All right. But the key thing here is the angles are all being cut in half. All right? And the same for the tan. It gets cut in half, or doubled if you go the other way. So if I have sine 6x and I expand it to 2 sine cos, what numbers go in for the angles? 3x. Because you cut it in half. What about the cosine 10a? I want all 3 of them. So what happens to an angle when you expand it using a double angle identity? It gets cut in half. So there's 3 cosine ones. There is cos squared minus sine squared. What angle should be in there? 5a. Or you can write 2 cos squared of something minus 1. What's the angle in there? 5a. And you could also write 1 minus 2 times sine squared of 5a. Those are all correct answers. You're going to see tomorrow, and depending on a certain proof, you'll choose one to make your life easier. I'll teach you that tomorrow. Okay? No, but it's going to be built into a question. It's not like just one. I won't give you a question like this ever. It'll be built into a question. So it'll be one step of a question. All right, tan x. If I want to expand that using a double angle identity, here's the tan one. What's my angle going to become if we start with x? Half x. So this is going to be 2 tan x over 2, 1 minus tan squared x over 2. All I did was plug it into the tan double angle identity, this one. But you just have to cut the angle in half. That's it. Sorry?
Oh, never mind. Sorry.
All right. Now we're going to go backwards. Okay, so we're going to take it when it's already expanded. And we're going to go backwards. So what does this become? As soon as you see a 2 sine cos, is that a sine double angle, a cosine double angle, or well, it's not a tan double angle because there's no tans. It's a sine double angle. It is this one right here. Okay? But what happens to the angle when you're going back now? It gets doubled. So what does the angle become if it's 4x here? 8x. So you get sine of 8x. Now we're used to seeing this. We saw this all the time last week. Right? That's sine squared plus cos squared always equals 1. This is cos squared minus sine squared.
Negative.
No. It's a double angle identity. So that's another hint. When you see cos squared minus sine squared, it's a double angle identity. Okay? So what happens to the angles when you're going backwards? They double. So if it's 1/2 a, what does it become? Just a. So cos of a. Like this?
Yeah.
That's ugly?
No, that's nice.
You'll see when we start to solve equations that it's a benefit to use that sometimes. All right, sine cos. Sine cos. Is this a sine or a cos or a tan double angle? It's a sine double angle. What's the problem with it? Well, no, the fractions are not a problem. I know nobody likes fractions, but what's the angle going to be? Let's talk about that first.
5.
Yeah, it's going to be 5. Double it, right? So you know your angle is going to be 5. But what's wrong with the way this is written? Look at the formula. Yes. You have to have a 2 in front. But can you just put a 2? Can I just go, oh, let's just put a 2. Oh, sorry. What? This one? No, you cannot pull stuff out of a trig function. No, it's all protected. You cannot pull that angle outside. But what can you do? What number can you multiply by that doesn't change anything?
2 over 2.
1. So we write it as 2 over 2, like that, right? Because that's really multiplying by 1. And then I go, okay, so I pull out a 1/2 and I rewrite it like this. Have I changed anything? No. So then you just kind of block this 1/2, pretend it's not there for now. What does this become?
Sine 5x.
Sine 5x. What's in front of it? 1/2. Okay, so if there is no 2 there, you can put 1 in as long as you multiply by 2 over 2. Okay? All right, I want to do one proof with you, and then we're done. Can I flip? I need you to go to question 5, please. This one right here at the bottom of the next page. Okay. We're going to prove this. This is a little simpler than what you're going to see on the test, but it's got some of the key features. So, as soon as you get this question, what should jump out at you right away?
1 minus cos 2x.
Yes. The 2 x's, right? Not the 2 different x's, but the 2x inside the angle. Everything has to be an x. Just one x, like this one, cotan x. Okay? So how do I rewrite sine 2x as just x? How do I cut the angle in half?
You expand the double angle identity.
Use the double angle identity for sine. Yeah, this one. 2 sine a cos a. So I rewrite it as 2 sine of x cos of x. What about the bottom? 1 minus cos 2x. I don't want cos 2x. So you got to get rid of the cos 2x. Now, this is where you have choices. Because you have 3 different choices. And technically, it doesn't matter. You can rewrite it as cos squared minus sine squared. You can rewrite it as 2 cos squared a minus 1. Or you can rewrite it as 1 minus 2 sine squared a. Which one do you want to use? There's one that makes things easier.
The bottom one.
Why?
Because then you have 1 minus 1 minus 2, so it's just not negative 2.
Exactly. So if you use this one, all right, you're going to get 1 minus, and this is important. When you're subtracting it, please put it in brackets, all right, or you're going to get things wrong. And I rewrite the cos 2x as 1 minus 2 sine squared x. It cuts the angle in half. And the reason I did this is because now I have a 1 minus 1, which makes that all go away. So I get 1 minus 1 is 0. Negative of negative 2 is 2 sine squared x. So we really simplified it.
Why is it negative of negative 2? Oh, so you're multiplying.
Yeah, you're multiplying the negative in, right? So I'm left with 2 sine squared x. There's only one step left here. What happens to the 2's? What happens to the sines? That one and that one are caught, and you're left with? What's cos over sine? And you're done. Please get rid of all the double angles using the identities and watch the brackets when you're subtracting, okay? 2, 3, 4, and 6, please. And 7, whatever. 2, 3, 4, 6, 7. We're almost done the unit. We'll just be practicing most of the time.